Let me switch back to demos. First, I'm enhancing my SSAS demo by adding a new mining model to my existing mining structure. Now the process is very simple. I just highlight the existing model and add a new mining model. I will call it TMDT as Target Mail Decision Trees, and I'm using the default algorithm Microsoft Decision Trees. By creating a model from an existing model, all of the structure was copied, so I have bike buyer as predicted attribute and all others as input except customer key, which is the key of course. Let me deploy the model. Processing was a little bit longer than processing with NeoBS only. Of course, decision trees is slightly more complex algorithm, and now let's harvest the results. So I'm going to view my decision trees model. Let me hide the legend for a moment and let me zoom out so we can see more of the tree. So what I can see is a tree and exactly the path how it has grown. The background of these classes is based by default on number of cases. So of course the darkest is the first class with all of the cases in it. So let's color the background based on number of bike buyers based on value 1 of the target attribute. Now I can easily spot interesting branches, for example this one or the other one up. When I highlight it, I get a quick tooltip. Total children not equal 2 and so on, and I can see the distribution of the target variable in this class. Or I can of course show the legend and get the details of this class. The whole path for this class is number of cars owned equal 2 and region equals North America, and number of children at home is 1 and total children is not equal to 2. So in this class I have more than 81% of bike buyers. Of course I can easily spot additional classes that are interesting by expanding some not so interesting branches. The other view is dependency network. Similar view I had in NeoBS. So decision trees again says that number of cars owned is the most important attribute for explaining bike buyer, and region is the second, total children is the third, number children at home is the fourth. This is slightly different than NeoBS have shown. Let me quickly show you the dependency network of NeoBS. So you see it agrees with decision trees that number of cars owned is the most important attribute, but the second most important for NeoBS is commute distance, and the third English education. Of course, results are slightly different because different algorithms have different logic of work, and that's why we will have to evaluate which of the predictive models gives us the best results.